Number 20, use the factor theorem to decide whether or not the second polynomial is a factor of the first. And we've been given 5x cubed plus 7x squared minus 5x plus 2, and our second polynomial, x plus 2. And from your book on page 307, the factor theorem states that for any polynomial function f of x, and in the case of number 20, f of x is what's here on the left, this polynomial. So for any polynomial function f of x, x minus k is a factor of the polynomial if and only if f of k equals 0. And for number 20, x minus k will be represented by x plus 2, this binomial here on the right. So all we're doing for number 20 is we're going to take the k value, plug it into f of x, and see if we get 0 or not. Because we're looking to plug in k into our function, and do we get 0 out? If we do get 0 when we evaluate, then we can say yes, x plus 2 is a factor of f of x. However, if we get something besides 0 out, like 13 or negative 6 or something else, then we can say that x plus 2 is not a factor. So let's see what happens. So we're testing f of k, but what is k? Well, we can see here that k is going to end up being a negative 2. So this is very similar to kind of what we were doing earlier, talking about horizontal translations, vertical translations. This ties in with horizontal translations, where we're going to take the opposite of what we see. And why is that? Well, let's look at that real quick, I guess. Why not? So if the standard form that we're looking at is x minus k, the standard here has a minus sign in the general form that we're looking at. But here we can see that we have x plus some number. So the only way that could happen would be x minus k, in this case would be negative 2. And if we were to distribute here, then you can see that we have, well, a negative times a negative gives a positive. So if you write it out like this, where you definitively show the k value with its sign, you can see how we would get x plus 2. The only way that happens is if k itself was negative, because a negative times a negative gives us the positive that we have in number 20. All right, so based on that, and I'll go ahead and get rid of that, based on that we can say that our k value is negative 2, and now when we plug in negative 2, let's see what happens. So plus 7 times negative 2 squared minus 5 times negative 2 plus 2. All right, let's evaluate. So we have 5 times negative 2 cubed is negative 8 plus 7, and negative 2 squared is positive 4. Here we can distribute, so we get plus 10 and then plus 2, and let's distribute and distribute. So we have 5 times negative 8, negative 40 plus 28 plus, well, 10 plus 2 is 12. And so finally, let's see, well, negative 40 plus 28 is negative 12. Negative 12 plus 12 is 0. So when we plug in our k value of negative 2 into f of x, we get 0 out, and that's what we're looking for. And when you get 0, you can say that yes, in this case, x plus 2 is a factor of f of x. So we will say yes, that x plus 2 is a factor of f of x.